Okay, all right. So today what we're going to do is we're going to combine a couple of things that you've learned in the past 2 years. All right. So the topic is speed, but we're going to combine that with slope. All right. More specifically, rate of change, average rate of change. Okay. All right. So let's go. Okay. All right. So now, since we're talking about speed today, okay, and how it relates to slope, I think it'll be great if we talk about what's the exact definition of speed first. Okay, so speed, right off the bat, the definition of speed is a formula, certainly. So speed is the distance, it's distance over time, or the ratio, right, of distance over time, or distance divided by time. Now, this is not unfamiliar territory, because in the 7th grade, at some point right before the state test, your teacher must have mentioned the dirt formula, right? What's the dirt formula? Same thing. Distance, it's rate, which is rate of time, right? Times time, right? The speed, actually, rate of speed versus time. So in a way, I guess I jumped too fast at this. This is the speed formula, right? Like this. This is just this, right? So if I'm solving for distance, like this example here, if I'm solving for d, I would just multiply t on both sides, right? So this is st equals d, right? Same thing here. So notice how we're using actually literal equations to redefine each of these variables. So if I'm solving for t, I would just divide both sides by s, right? So t is equal to d over s, distance over speed. So all three of these are synonymous. They're the same thing, okay? The first instance, we're talking about speed. The second instance, we're talking about distance. The third instance, we're just talking about time. So let's apply what we know here then, okay? So I just want to show you a couple of examples. Now, very, very straightforward. I'm not even going to do all of these, actually, because that would be silly. All right, so let's say, right? And I just want to get your, let you get your footing, all right, into this topic. So an airplane travels 700 miles in 2 hours. What's the average speed, right? You see that, right? Average speed, average rate of change, slope, right? Delta y over delta x, same thing. So what's speed, right? Speed is distance over time. So speed is the distance over time. So that's 350 miles per hour. And that's it. That's how you do these sort of questions, okay? Let's try one more, okay? Let's do the one on the right side. So in a baseball game, the ball traveled 350.7 feet, 4.2. What's the average speed again, right? Speed is distance over time. So that's 350.7 over 4.2 seconds, right? They're not even asking us to change this to miles per hour, which is interesting, because in baseball it's usually miles per hour. So let's say 4.2, 83.5, yeah, 83.5 feet per second, okay? And that's it. That's how you do these sort of questions. Now we're about to take a huge leap, okay? Huge leap into these 3 questions. Now, the great thing is that we only have 3 questions, but the bad thing is that these are very long questions. Okay, so I'll try to keep it under 15, okay, because I know the videos in the last 2 days has been very, very long. So let's see. All right, now the distance, okay, I'm just gonna write this. Distance is equal to the rate of speed, okay, so I'll use s, you can use r, doesn't matter, by the time travel, right? So this is the second formula, right? That's this formula, right? Which is the same thing. Now, in a way, it also makes sense, right? Looking at this formula, how far you go depends on how fast you go for how long, right? I'll repeat. How far you go depends on how fast you go for how long, right? That makes sense. So that's the formula now. What is it asking you? If the distance is measured in feet, okay, so this is measured in feet. Let me use parentheses for that. And the time is measured in minutes. Oops, erase that. And the time is measured in minutes. Then the rate of speed is oh, wow. Okay, man, if you see this question on the regions, I think it will make you very happy, right? So you notice how I organize my information also, right? So that's a good strategy. Now, what are they asking for? Okay, so the rate of, so basically they're solving for, they're basically saying, hey, look, solve for speed. That's really that's pretty much what they're asking for. So how would you solve for speed, right? Think about that, right? Yeah, I just divide both sides, right? Now, I mean, if I set it up like this, I can just divide it like this, right? So I'm just treating it like it's a literal equation. So these cancels out, I'm left with speed, and that's feet per minute. And that's your answer, okay? So how is rate expressed in which units? That's how you express it, right? What's the unit? Feet per minute. That's 1 unit, by the way. These are not 2 units. This is 1. The unit is feet per minute, okay? Explain how you arrive at your answer. You can say, hold on, let me see if I could find the official answer. Okay, hold on. Okay, I just looked it up real quick. Okay, so you can say the unit is feet per minute because speed is expressed as this, speed is expressed as distance over time. That's it. So in other words, again, like this is by this point, I guess you guys kind of catch the drift, right? That when we explain answers, right, just throw the definition back at them. All right, so this is the unit because speed is distance over time. And it's true, it's not false. I mean, you solve for it. I mean, right? You know what I'm saying? So, okay, all right. Number 2. I'm going to bring this down because I don't want you to see that. All right, okay. So let's see. Loretta and the family are going on vacation. Their destination is 610 miles from home. All right, let me get my pen ready. All right, so let's see. Loretta is going to share some driving with her dad, so there are 2 people here, right? So there's Loretta and dad, right? So let's see. Her average speed is 55 miles per hour. So you see how I'm just gathering information, okay? Let's see, Loretta, that's 65 miles per hour. You know why? Because then I don't have to keep going back to read like this whole paragraph. The plans for Loretta to drive for the first 4 hours, and then for Dad to drive the rest. Okay, so how many hours, right? And then determine number of hours it will take. Okay, all right. So now the whole thing is 610 miles from home. Okay, so she drives 55 miles per hour for 4 hours, right? So now, I don't want to set up as an equation, but if you want to, you can, all right? So this is 55 times 4 is 220, is that right? Yeah, 220. So this is 220 what? Miles, right? Okay, plus her dad, right, which is 65 times some amount, and that should be 610. Oops, I just made an equation. All right, so I gotta subtract that. So I'm gonna subtract 220 from 610. So 65 times what will give you 610 minus 220, right? What is that? Oh my God, I just realized I'm literally just going over the questions with you without letting you try it. You can try the next one, okay? All right, 390. So I gotta divide both of them by 65, right? Because the question is 65 miles per hour for how long will let her dad travel the rest of the way, which is 390. So how much does the guy have to go? How long, actually, does the guy have to go? Divided by 65, 6 hours. Okay, so the whole trip, now, I don't think the question is asking you how long the dad has to drive. The question is how many hours it would take for the whole family to get there. So it's 6 plus 4, right? 4 plus 6, 10 hours. All right, not done yet though. Not done yet, all right? Now, if Loretta has been driving for 2 hours, right? So again, right? Let me reset this up using a different color. So Loretta, right? And her dad, let's see, if Loretta drives for 2 hours, so 55 miles per hour for 2 hours, right? That's 110 miles. Yeah, am I right? Yeah. Her dad takes over, right? Now, they still have to do the 610, right? So the dad has to cover 500 miles. So you see how organizing information, all right, in whatever way really helps you, okay? Now, let me finish reading the question. After Loretta is driving until she gets tired and asks her dad to determine the nearest 10th, how much time? Okay, so they want to know the time. Right, because dad drives for 65 miles per hour. All right, so all the information's there. I just got to put it all together. Okay, let's see. Determine how many time saving. Okay, so let's see how much time is saving for remainder of the trip. Okay, now let me think for a second. Saving, as in saving versus the original plan, right? The 4 hours and 6 hours, or saving by not otherwise. Hold on, let me press pause and think about this real quick. Okay, yeah, it's versus the original, right? Versus the original 10 hours. Okay, all right. I momentarily lost track of that. Now, let's see. If her dad is going at 5, so time, right? Time is, let's look back. Time is distance over speed, right? So time is distance over speed, which means it's, oops, lost track. All right, let's see, 500. Right, by the way, you don't even need to look at the formula. I mean, you could figure that out on your own, right? So 500 over 65, right? Because the person have to travel 500 miles over 65 miles per hour. So that's 7.7 approximately. Right, what did it, nearest 10, okay. I was wondering if it's okay for us to round that. So this is approximately 7.7 hours. Now, what's the question? Okay, so 2 hours, 7.7 hours, that's a total of 9.7 hours. How does this compare to the original? Yeah, it's 0.3 hours saved. Okay, so that's it. So those are the two parts, 10 hours and then 0.3 hours saved. Okay, all right, not bad. Now, this next one is tough. Okay, so I'm just gonna let you read it, and then what I'm gonna do is actually, I'm going to go over the equation part with you. So I'm gonna highlight that right now. Let's see, what am I, where is it? Write an equation, there we go. Okay. All right, so, yep. So press pause right now. Okay, wow, okay, that took me like 5 minutes to do, okay? Now let's see, okay, where do I start? I'm just gonna look at, so I color-coded this because there are 3 parts, right? So the first part is in blue, as you can see, right? In blue here. The second part was in green. And the third part was in purple. Okay, so let's take a look. Now, first we got, so what I did was this, right? After 32 minutes, let me use a highlighter. All right, I'll stick with yellow. It says after 32 minutes, it went 192. So I literally, the moment I saw that and I knew that we were doing slope, I just wrote them as coordinates, okay? I'm not even hiding it. Okay, so we're just gonna do slope, all right? After 92 minutes, we're at 762, right? So 32, 192, 92, 762, what do they want to know? They want to know the speed, right, in miles per minute. So I went straight to the formula. and solve for it. So that's 9.5 miles per minute. Okay, that's how I got that. Now, second part, what do they want to know now? Write an equation to represent the number of miles of plane. Equation, so now, don't get thrown off just because someone said equation. It's not like the first time you've done an equation, right? So right off the bat, I knew that this is a blast from the past because we're talking about unit rate here, right? So this is a unit rate, right? And the unit rate is represented by the letter K, right? So if you remember in seventh grade, you would have y equals kx, right? Remember when you have to draw a graph, right, with a line that's straight through the origin, you have to write the equation there. That's what this equation is, okay? So once you do that, you knew, oh, y equals, right? Look, they're saying, hey, use y and x. They're not hiding it either. So all you have to do is just put k, right? Replace k with the unit rate, which is 9.5. That's it. It's not as hard as you think. I know, I understand. When I saw this question, I was like, oh my God, I gotta do an equation too, all right? But not that hard. Now, this last one, I had to go really, really slow, this part. Okay, how are we doing on time? 16 minutes, all right. So this one, okay, the first 32 minutes, it was cruising, right? I'm just using, this is a given. This is given information, nothing new here. This part requires a lot of calculation, all right? Slow calculation. So what is it? You cruise at, all right, that's my favorite actor, all right? Cruise. Now it's Brad Pitt, actually. All right, so I have to subtract, because they said the limit was 2 hours, right? The interval was 2 hours. So if I take 32 minutes from 2 hours, I get 88 minutes, right? So I got to figure out how far this plane went in the 88 minutes. So that's why I did 88 multiplied by the, right, 9.5. And that's how I got 836. And then at the end, I just took this 192 and I added that, and then I got 1028, all right? And I checked the answer key, and so I know I'm right. Okay, and that's how we do it. All right, I'm gonna sign off here. So the questions there weren't many, but the questions weren't easy. Okay, so if you got this, congrats, good job, and I will talk to you guys tomorrow. Okay, bye-bye.
OMG, that was so good.